right, guys, today's day 85 of the 100 Days of LeetCode. We got medium problem, 475 heaters. Let's do it. So, winter is coming. During the contest, your first job is to design a standard heater with a fixed warm radius to warm all the houses. Now, every house can be warmed as long as the house is within the heater's warm radius range. Given the positions of houses and heaters on a horizontal line, return the minimum radius standard of heaters so that those heaters could cover all houses. Notice that all the heaters follow your radius standard and the warm radius will be the same, I think they meant. So in example 1, we have heaters at position 2 on a number line and we have houses at position 1, 2, and 3. Now, this heater is going to warm any single house within its radius. So we want to find the minimum radius that's going to warm all of these houses. And of course it's 1, because if it's 1, then it's going to heat basically positions from 1, 2, and 3 on a number line, and everything in this array, in this list in Python that we're going to be using is between 1 and 3. Now, it gets a little more complicated when you have multiple heaters, but we can look at example 2. We have houses at every position from 1 through 4. We have heaters at 1 and 4. And again, our output is 1 because this 1 heater can take care of houses at 1 and 2, and this 4 heater can take care of houses at 3 and 4. The explanation pretty much explains that. Now, example 3, we have houses at 1 and 5, and now we only have 1 heater at position 2, and this needs to heat both the houses at position 1 and the house at position 5. So we need to have an output of 3 because, of course, 5 minus 2 is 3. All right, so we want to solve this problem. Now, our solution is going to basically look a little bit like this. What we're going to be doing is we're first going to be implementing sort of a binary search function so that we can search efficiently the list of heaters and find an index that we can then use to figure out the sort of the left closest heater and the right closest heater to any given house, right? So this is going to involve also sorting the heaters array so that it's in order. That's going to help us. That's going to enable us to do the binary search. And then once we have sort of that sorted list, we have a binary search function. We can just loop through all the houses, figure out the left closest heater, the right closest heater to every single particular house. And through looping through all the houses, we can then figure out the minimum distance that we need to set our warm radius. So let's start off by defining our binary search function. It's going to take the heaters and it's going to take a house as a parameter. Now we're going to create like in any binary search, we're going to set low and high. So low is going to be 0, high is going to be the length of the heaters list. And we're going to do, well, low is less than high. We're going to figure out our mid. So mid is just low plus high minus low, integer divided by 2. So this, I'm just assuming that you know what binary search is. If you don't, I'll link some videos where I explain it a little bit better, but it's basically a way to search a sorted array efficiently. So I'm not going to be explaining the details. I'm just sort of going to be implementing it, and I'll point out one detail that's important. But so we get our mid, and then, of course, what we need to do is we need to basically update either our low or our high, right? Now, so we can say if heaters mid is less than our house, right? And again, it's a little bit confusing, but this house, all this house is it's just going to be the position of the house on the number line, right? That's what these houses are represented at. So it might be 1, but that's just a position on a sort of theoretical number line. So basically, if the number that we have at our mid index is less than house, we are going to update our low. Okay. And else, what we're going to do is we're just going to set our high to be equal to our mid. Now, usually in binary search, you want to set your high to be equal to mid plus minus 1, excuse me. The reason why we're not doing that is because here we're always going to be returning our low. We're not going to be returning our mid, as is normally the goal of binary search, right? We return mid when we find the correct index. Simply looking for an index to return so that we can work with in sort of the next phase of our solution. Okay, so we've written that. And what's next is we want to, like I mentioned before, we want to sort the heaters array, right? We can't do binary search if it's not sorted. And we want to create our answer variable, and we're going to set that to float negative infinity. And the reason why we're setting it to negative infinity is because in this loop, we're going to be basically setting it to the return of a max function, right? And that's basically, we always want to set it to the lowest possible number so that it's that the max function, you know, we're guaranteed to have it triggered. Now, yeah, so we can do that. Now, inside this house and houses, okay, what we're doing here is we're iterating through the houses list, and we're first going to find an index that we can work with, right? That was the purpose of this whole function. So we're simply going to take binary search, we're going to pass in heaters and house, and now we have our index. So now, based off of this index, we can now find sort of the closest left heater and the closest right heater to our particular house. Now, there are some corner cases, so there could be a situation where there is no house on the left, and there could be a situation where there's no house, or excuse me, there's no heater on the left and there's no heater on the right, and we're going to check for that. So what we're going to say is we're going to say if cur index is greater than 0, all right, we're just going to say left distance is equal to, so now we got to think about it, right? The distance on the left. So this means our house is greater than our heater index. So we can say left distance is equal to house minus heaters index, excuse me, I used cur index minus 1, okay? And if cur index is not greater than 0, then we're going to say left distance is equal to, we're going to use here float infinity, okay? And now we're going to do sort of the same, but on the other side, if cur index is less than length of heaters, then our right distance is equal to our heaters at cur index minus our house. And the reason why these are flipped is, of course, we have one situation where the house is greater and we have another situation where the heaters at cur index is potentially greater. And we can say else right distance is equal to float infinity. Now at the end of this loop, we're going to update our answer. So our answer is going to be the maximum value of the answer that we previously had, or the minimum value of left distance and right distance. So let's look at this for a second. So we have our answer, right? And this is simply that, this is simply sort of the minimum possible radius that we have computed up to that point. And now we have, for the given house, we have a left distance and a right distance. Well, for that given house, the closest possible heater that can heat it is going to be the minimum of the two distances, right? That's the minimum radius that the heaters need to have for that house to be heated. And the reason why we're doing max of that value that I just explained and answer is because we need to figure out the minimum possible value for all of the houses to be heated. So we need to take the max because it's possible that this number is greater than the previous answer. And if that's the case, we need to find the maximum because the previous answer can no longer heat all of the houses. Okay, and now we want to return our answer. Okay, so that's how you can solve that problem. That was day 85. Hopefully you guys liked that video, and we'll be back tomorrow with day 86. Thanks for watching.